So now this is one of the more complete problems here. We're going to work on page 123, problem 3.92. The problem says zinc metal reacts with aqueous silver nitrate to produce silver metal and aqueous zinc nitrate according to the following equation. And note it says that it is unbalanced, and it is in fact an unbalanced equation. So let me write the equation out. Zinc solid, which is what it says, zinc metal, plus silver nitrate, which is aqueous, that means it's dissolved in water. And I did not need the parentheses. Well, just have it. Let me fix that. NO3, which is aqueous. I was getting excited about my aqueous there. Which will give us silver, which is a solid, and zinc nitrate, which will be aqueous. Because anything combined with nitrate will dissolve in water. I will say that again and again and again, and one day it will mean something to you. First thing I need to do here is balance it. We'll go ahead and do that. On the left-hand side, we'll see we have zinc, we have silver, and we have nitrogen, and we have oxygen. We have, on the reactant side, we have 1 zinc, we have 1 silver, we have 1 nitrogen, and we have 3 oxygens. On the product side, we will find that we have 1 zinc, we have 1 silver, we have 2 nitrogens. Because of that, you'll see right here, this little subscript there tells us that we're multiplying that whole parentheses by 2. And then we have 6 oxygens. We're going to go ahead and balance the nitrogen, make things work. So we'll add a coefficient of 2 in front of the nitrogen over here. And that gives me now 2 silvers. And so on the other side, we've got to get 2 silvers also. So we'll put a coefficient of 2 there. All right. And so is the oxygen balanced? We had 6. Well, yeah, it is, because now I have 2 times 3, which is 6. So that was it. So now oxygen is balanced. So there's our balanced reaction equation. All right. Let's get into the next part of it. It says, what mass of silver metal is produced when 25 grams of zinc? So here we have 25 grams. Wait, let me write it out with significant figures. Whew, always forget those. 25 grams of zinc is added to a beaker containing 105.5 grams silver nitrate. 105.5 grams silver nitrate dissolved in 250 milliliters water. Determine the mass amounts of each substance present in the beaker when the reaction is complete. All right. So, first off, we got to figure out how much silver metal is going to be produced. Looking at what's given in the problem, somebody's driving up. All right. So in our had somebody came to the door. So in our description for the problem, it tells us it's in 250 milliliters of water. That's not important at this point. That has nothing to do with the limiting reactant. Now, when we have 25 grams, forgot to put the G there, of zinc with 105.5 grams of silver nitrate, what we've got to do is find out how many moles this is. So to determine the number of moles, we've got to find the gram formula weight or the molecular mass or whatever you want to call it for each one of these. So we'll look at zinc here. And we will know that zinc, we'll look on the periodic table, we'll find zinc is 65.38. 65.38 grams per mole. And then silver nitrate, it's a little more complicated because we've got silver plus nitrogen plus 3 times the oxygen. So we'll look up silver, and silver is 107.87. And we'll add that to the nitrogen, which is 14.01. And we'll add that to 3 oxygens, and oxygen is 16.00. We'll add that up. So when we add that up, we will wind up with 169.88, and that is grams per mole of the silver nitrate. Oh, that's an A, not an N. Okay, so now we got to figure out which one are we going to run out of first, the silver nitrate or the zinc. Well, in this particular reaction, we're looking at the limiting reactant. So we'll pick one of our reactants. It doesn't matter which one. I'm going to pick zinc just for, the brevity's sake of it. And let's see, from zinc, which we have 25 grams of zinc. We're going to need to go from zinc over to grams of silver nitrate. You see? So 25 grams of zinc, and we know that there is 65.38 grams in 1 mole. And I put grams on the bottom because we want to get rid of grams of zinc, because we're trying to get to grams of silver nitrate. And on the top we have 1 mole of zinc. And then from that, I'm not drawing my horizontal line, I'm just using the one on the graph paper there. We know that the ratio between zinc and silver nitrate is for every 1 mole of zinc, we will use 2 moles of silver nitrate. Where does that come from? Well, that comes directly from the reaction equation here. See my highlighter? So back here, then we would have moles of silver nitrate, but we don't need moles of silver nitrate to make our comparison. We need grams of silver nitrate. So from here, I'm going to multiply that out. We're going to have 1 mole of silver nitrate, AgNO3, and the mass of that is, from up here, 169.88. Now, before we do our actual math, let's make sure our units cancel out the way that they should. Here we have grams of zinc, cancels with grams of zinc. We have moles of zinc, would cancel with moles of zinc. Moles of silver nitrate cancels moles of silver nitrate, so the only units left over are grams of silver nitrate. So in my answer there, I have grams of silver nitrate. Okay, so I need to take this top number 25, we multiply that by 1, and then multiply it by 2, and then multiply it by 169.88. So we're going to multiply that out, times 2, times 5, equals, I got 8494 grams silver nitrate all over, and then the bottom part is 65.38. Now, what we did there is we multiplied everything on the top. Let's draw a line that goes right through here, and then you'll divide it by everything on the bottom multiplied out. Well, now we got this ratio. Now I just got to punch in my calculator. Divide by 65.38, and I get 129.92. 129.9, well, 174. Let's make that blue so it's matched right. Okay. So, significant figures. When I'm multiplying and dividing, my significant figures always goes by the least number of significant figures. We'll see here we've measured out 25.00. This is 4 significant figures here. This is 5 significant figures. All these others have exact values, so those are infinite numbers. So my least number of significant figures is 4, so I can only have 4 in my answer, so we would round that to 129.9 grams of silver nitrate. Now, what did we actually calculate? We just calculated the maximum amount of silver nitrate that you could get if you reacted 25 grams of zinc with an unlimited amount of silver nitrate. So this is the max that we could get from that zinc amount. Okay? The amount we actually got, the amount of silver nitrate that's max, not produced, the maximum amount used up. Well, the amount that we actually have that we can actually use is just this, 105.5. Well, for 25 grams of zinc to react completely, we would need 129.9 grams of silver nitrate. Well, we don't have 129 grams of silver nitrate, so that tells us that this value is the limiting reactant. Okay, the limiting reactant is what's going to get used up completely in the reaction. We'll have zinc left over. That makes the problem much more interesting when it happens like that. So we know we'll have zinc left over from this reaction. Now we've got to figure out how much zinc is going to be left over. Now some folks would actually do this all in one problem. They would actually go ahead and say calculate it in both directions, don't figure out what's going on, and then compare the numbers in the end. I think it's best to think about what's actually taking place. In this case, if we use the zinc that was given to us, we would need 129.9 grams of silver nitrate. But we don't actually have 129.9 grams. We were only given 105.5. You see, so the number's lower. Don't use this in considering your limiting reactant. This is just the molar mass, or the gram per mole weight, or gram per mole mass, whatever you want to call it. This molar mass here, that has no factor in it except for converting from grams to moles. That is just for this step here in the problem. All right, so let's go with this and figure out how much zinc would actually be used up. So we started with 25 grams of zinc. How much zinc would we actually use up using 105.5 grams of the silver nitrate? So for that calculation, let's start out with 105.5 grams of silver nitrate. I don't know why I keep jumping the A and going straight to the nitrate when I try to write this. All right, so there's that. We need to go to grams of zinc that would be produced. So there's our grams of silver nitrate. On the bottom of this, we put the molar mass of silver nitrate, which I think was 169, what was it, 169.88 grams of silver nitrate in every 1 mole of silver nitrate, right? Then from there, we need to look at the ratio between silver nitrate and the zinc. And we'll see that our ratio is 2 to 1, 2 silver nitrates, 2 moles of silver nitrate for every 1 mole of zinc. Then we've got to go from moles of zinc, we'll put that on the bottom again, to grams of zinc. Well, we got to have the formula mass or formula weight of zinc, which is 65.38. And that's for 1 mole of zinc. Okay, check our units. Gram silver nitrate, mole silver nitrate, mole silver nitrate, mole zinc, and so we wind up with just grams of zinc. Okay, do the math. We get 105. Let me get a calculator up here. 105.5 times 1 times 65.38. I get 6,897.59. I show this step. I actually do this when I'm working these by myself because I like to make sure that if I make a mistake, I can figure out where it is later. Then on the bottom, we got 169.88 times 2, which gives us 339.76. And the units that are left on all of this is grams of zinc. So we just got to, it's just the math here. So we're going to get 6897.59 divided by 339.76 equals 20.301. grams of zinc. Significant figures come into play again. We've got 4 is our least number of significant figures, so our answer needs 4. So this will be 20.30 grams of zinc. Okay, now that is the zinc that is a reactant. So this is how much is used up. So we're going to only use 20.30 grams. Now, we want to know the mass amounts of each substance present in the beaker when the reaction is complete. Okay, so we need the mass amounts of each substance that's going to be present in the beaker when it's all complete. Let's think about this beaker here. Okay, in this beaker, we added in, it had silver nitrate, it had zinc, it had water. It also winds up with silver metal as a product, and it ends up with zinc nitrate as a product. So those are the things we've got to pull out of here and figure out how much of each we have. So we're looking for the mass of all this, etc. All right, so we know that the limiting reactant, we determined on this page, the limiting reactant is actually the silver because we only have 105.5 grams. Let me go highlight that. 105.5 grams of silver nitrate. So that's what all of our calculations are going to start from, is the limiting reactant. So go back over here, 105.5 grams of silver nitrate. We need to determine from this how much zinc metal would be produced. How much silver metal would be produced. I said that completely wrong. And we also need to determine how much zinc nitrate would be produced. So it's pretty straightforward from here. Same thing we did before, 169.88 grams silver nitrate. And that is for 1 mole of silver nitrate. Now from that, we need to go to zinc nitrate. So what is that ratio? I forgot the balanced equation. Zinc nitrate, we have 1 zinc, so we have 1 mole of zinc nitrate divided by 2 moles silver nitrate. I know, I drew my line. I was trying not to draw my lines. And then we've got to go to the molar mass of zinc nitrate. So we've got to figure that out. And that's in 1 mole. All right, so let's come over here. We have zinc in here. We have nitrogen taken twice. And we have 2 times 3, which is oxygen, taken 6 times. So I got to add all of that up. So zinc, I'll look at 65.38. Nitrogen is 14.01. I said 19, I don't know why. And oxygen is 16.00, but we have 6 of them, so that is, I believe, 96.00. Doing that right? Yeah, that's the math's right. Add that up. 65.38 plus 14.01 plus 96. 175.39, and that is grams of zinc nitrate in 1 mole. So we take that number over here, 175.39, and you may say, hey, wait, Mr. Hurt, wait. How about your significant figures? Our least number is 4 in all of this. So when we're done with our multiplication here, we're going to look at 4. Our answer there has 5, but that's inconsequential at this point because in the end, the lowest number is 4. There's a 1 here. Just make sure we didn't miss that out. So I do my math. I get, let's clear that, 105.5 times 175.39. And on the top, I got a big number, 503.645. That's 503. And on the bottom, I get 169. Oh, you know what? I don't have to do that again. You know why? Because remember when I said, hey, I like to write these numbers down? It's because that number is what we get on the bottom. Because they always come in handy. This would be grams of zinc nitrate. So I'll just divide that by, let's see, 18503.645 divided by 339.76. And I will get 54.46. 54.4609 grams zinc nitrate. Four significant figures you'll see. So we only need 54.46 grams ZnNO3 2. And that is how much is produced. Okay, so 54.46 grams of the zinc. I don't know what is wrong with me today. I keep on writing N in the place of Z. Zinc, of the zinc nitrate. All right, so now we have our zinc nitrate. We know how much zinc was used up. We also need to know how much silver metal? Yeah, silver metal is produced. So that's going to be our next calculation. Now here's the cool part. As I just said, a lot of this will wind up being reused. So I'm going to take all of this section here. Let me highlight all of this. And all of that's going to be reused again. Okay, so I'm going to see if I can do that with my pen. Oh yeah, I can. Cool. So let's take that, circle that, come back around up here, and I'm going to copy that. So on the next page, I'm just going to, well, you know what? I don't know how to paste. Oh, paste. There we go. Ta-da! So we're going to use that whole section again. Silver nitrate, limiting reactant, we'll use that again. There's the mass silver nitrate. From here, we need to go to silver. For every 2 moles of silver nitrate, we use 2 moles of silver is produced. And then we need the molar mass of silver, molecular mass of silver, which is 107.87 grams of silver. And for every 1 mole of silver, when we're canceling things out, we'll see that 2 over 2 cancels out. So that makes takes out a little step there. So we'll wind up with 105.5 times 107.87 on the top, which is 11,380. 0.285. All of that would be over 169.88. Because the 2's canceled out. And their units there would be grams of silver. So I divide that, I get 66.9901 grams of silver. 4 significant figures is the limiting factor there, so we get 66.99 grams of silver. And that is how much is produced. All right, so let's go back and think about that problem again. And it says, determine the mass amounts of each substance present in the beaker when the reaction is complete. Each substance present in the beaker. So let's think about our beaker again. And inside this beaker we have, we added silver nitrate, we added zinc, and we produced silver and zinc nitrate. Man, I just will get zinc eventually right. And don't forget that we also have water. Well, how much of this do we have left? Well, we said that the limiting reactant, so this is what we're looking at. So we said that the limiting reactant was a silver nitrate. That means the silver nitrate gets completely used up. So the amount of silver nitrate in the end is going to be 0.000 grams silver nitrate. Because we just said all of the silver nitrate got used up. Okay, zinc. How much zinc is left? Well, let's go back and look at our problem. We were only able to... Oh, where's my zinc calculation? Oh, it's on the next page. We were only able to use up 20.30 grams of zinc. All right, so if we used 20.30 grams of zinc, and we started out with 25.5... 25.5? I think that's what the problem was. No, 25.00, sorry. And we wound up with, we used up 20.30, we subtract that. And so the amount of zinc we have left is only going to be 0.70 for 4.70 grams of zinc. Now you may ask about significant figures. Well, when you add and subtract, your significant figures goes with the least number of decimal places. And the least number of decimal places here is 2. So in that answer, we would only have 3 significant figures because the 25 and the 20, you lose a significant figure in the front. So zinc is found at this point. How much silver? Well, we just calculated the silver, 66.99 grams of silver. You'll see that right here. That was this calculation. So silver we've got. Then we've got zinc nitrate. Let's go back to the zinc nitrate one. Here's 54.46 grams of zinc nitrate. Oh, how much was that? 54.46. Oh, short-term memory. Grams zinc nitrate. Remaining in this. But you know what else? We got water. Now, in the reaction equation, was water used up? No, it wasn't. So we started at about 250 milliliters. And what do we know about the density of water? Well, the density of water is about 1 gram per milliliter, so we would have about 250 grams of water. This is what would be in the reaction when it's finished. In the reaction flask, that's what you would have.